Welcome to your Chapter 1 review. So here is an exhaustive list of all of the topics that we covered in Chapter 1. So I would say just be very familiar with all of these terms, their definitions, any features about them, any properties associated with them, how to apply them in geometry problems, and how to identify them mathematically or to name them geometrically. Okay, so I know there is a lot of material in here. So what we're going to do is practice some more of the hands-on problems, if you will. So this first problem says, determine the length of segment AB. Well, here is segment AB. It's the whole thing. And we can see that segment AM has a length of 4x minus 13, and MB has a length of 3x minus 5. Now, the answer I am not looking for here would be for you to simply just add these two pieces together and go, well, there's 7x's altogether minus 18. Done, and you move on. Because that is not the answer that I'm looking for. I am wanting to know actually how long is segment AB. Now, if I don't know the length of segment AB, I simply just can't use the segment addition postulate to take little segment plus little segment equals big segment, because I don't have a value for the big segment. I don't know how long segment AB is as a number, nor do I have an algebraic expression for its length, like I do for these two smaller segments. So the other thing that you got to pay close attention to is there are these markings that are on segment AM and segment MB. And those markings are telling me that those two segments are congruent to each other, or they are equal in length to each other. So if those two segments are equal in length to each other, then I should be able to set their algebraic expressions equal to each other. So now I can just do a little two-step algebra equation here. So I can subtract my 3x's over to my 4x's, and at the same time I will add over this 13 over to the negative 5. So that's gone, that's gone. I'm left with just really one x, or x equals negative 5 plus 13 is 8. Now, that is not necessarily the length of segment AB, but that is the value of x for this particular problem. So if I plug 8 back in, and what we should notice is that these come out to be the same length, okay? And if they don't, then that's telling me I screwed up my algebra somewhere, or maybe I set up the problem incorrectly. So let's see, 8 times 4 is 32. 32 minus 13 is going to give me, what, 19. And over here I got 8 times 3 is 24. 24 minus 5 is 19. So hey, these are a good match, which lets me know my algebraic answer of 8 seems like it's a good answer. So now altogether, how long is segment AB? Well, it's made up of a 19 and a 19, which means altogether it is worth 38 in length. So we use some congruent markings here. Really, we're saying that point M, I mean, we didn't really use this term, but we could talk about it. Point M is the midpoint of segment AB. Because of those congruent markings were in place. We could say point M bisects segment AB because of those congruent markings that were in place. But if it wasn't for those congruent markings, we would really be stuck in the problem. And then at that point, the only thing you could really tell me about the length of segment AB is, yes, it is 7x minus 18, but we don't know what x is. All right, second problem. We've got a midpoint, we're talking about an end point, and we want to know the coordinates of point G. And so G and H end up being what we call the end points of our segment. And M, the midpoint of GH is M, so M is right in between. So again, I'm going to show you two ways of solving this one with the graph and one without the graph. Okay, so it's always good to know how to solve a problem in more than one way. So let's graph what we know here. The midpoint M is at negative 6, negative 3. So there's negative 6, negative 3. There is M, the midpoint. And H, one of the endpoints, is at negative 4, comma 4. So there's H. So what that's telling me is H is one of the end points. M is in the middle. So that means I need to go over the same amount just on the other side of M. And then that'll tell me where point G is. Well, this might be a little tricky with the graph that I have in particular because it seems like we're going to run out of room here. But we will scale this thing down. We'll kind of adjust it just a smidge. There we go. So again, what we can do is basically use kind of the idea of slope here, rise and run, but we don't have to do rise and then run necessarily. But if we went down 1, 2, 3, 4, 5, 6, 7, and then ran over 1, 2 to the left, so we went down 7 and then left 2. For m to really be the midpoint, we would need to repeat that same exact slope. So I would need to drop down from m, 1, 2, 3, 4, 5, 6, 7, and over 2. So this point, that would be right here, but again, it's off my graph. This is why this particular method isn't necessarily the greatest method to do. It is one of the easier methods, I will say, but if you run off the graph, well, now you got to make sure that you're making your extended graph really kind of to scale here. So here's what we can kind of do. So this is going to be 2 units, right? So we know it's going to be here. So we know the x coordinate is going to be -8, comma, and then how far did it really go down? Well, remember, m was at -3, so we went down another 7. 1, 2, 3, 4, 5, 6, 7. So here's -7, -8, -9, -10. So -8, comma, -10 is where g is. All right, so I was able to do that with the graph to some degree. I had to extend it a little bit. So now let's see, how do we do this mathematically without the graph? Because again, it's always great to know how to do a problem more than one way, just so you have extra tools available in your tool belt. All right, so the midpoint formula. So if I had a midpoint, and I had x comma y as that midpoint, the midpoint was equal to, and this is where we took the average of our x coordinates of our endpoints and the y coordinates of our endpoints. So again, this is like saying h -4, 4. That's like x1, y1. And what we're trying to figure out with g, we could call those, this thing will write more smoothly here. Let's try it again. There we go. We'll call g x2, y2. Okay? So let's plug in what we know. So the midpoint we know, right? This is -6, comma, -3 equals, and then x1, that was -4, -4, plus, we don't know the other x coordinate, and I could have these flip-flopped around. It really doesn't matter. I could have x -4 if you wanted to, or x plus -4, divided by 2, and then y1, the first y coordinate of one of our endpoints is 4, plus, I don't know the other y coordinate. That's what I'm trying to figure out with point G. And I add those together and divide by 2, because again, the midpoint is like the average of our two endpoints. But we got to think of it as really two averages, the x coordinate average and the y coordinate average. So now we get to take this and make two equations, okay? Because first we have to talk about the x part of this. So here's the x part of this, and it should come out to be this x coordinate for the midpoint. So -4 plus x divided by 2 should give us the -6. Now, the way I had always kind of set this up next was, well, let's just always double both sides, and that'll get rid of this divided by 2, and then I just got my -4 plus x equals -12. Add the 4 over, and we get x equals -8, which, hey, matches my -8 that I had over here. And then we get to do the same thing. Let's do a different color here for the y coordinates. So the 4 plus second y coordinate divided by 2, the average of the y coordinates, better give us -3. So again, double both sides. So I'll just have the numerator up there, and then that'll cancel out with that divided by 2, and then -3 times 2 is -6. Subtract the 4 over to the -6, and we get -10, which, hey, is the same y coordinate that we got earlier. So there's two ways to figure out the other endpoint. All right, next question. You are building a patio of the back of your house. The diagram shows the plan for the patio. Find the area of the patio to the nearest square foot. So this thing right here, that is the patio. And what they mean by house down here, there's a little bit thicker of a line. They're saying the house is right here, and then you're going to walk outside of the house, and then this is your patio walking out back. Nope, didn't want to do that. There we go. Okay, so we need to find the area of this thing. And this isn't a typical shape that we would normally find, right? So again, I'm going to show you a couple different ways. Number one, what we could do is try to break down this shape into smaller, more manageable shapes. And I kind of get a feel, here's one thing you probably don't want to do, is just do this. Because we got a triangle here, but we don't have a really good base, right? Because I don't know the lengths of any of those sides just by counting. I'd have to do some Pythagorean theorem. So maybe not put it there. But what if we cut this over and we get a nice rectangle down here? And we're like, all right, we're getting somewhere. We're getting somewhere. And look at the shape that we now have left up here. It's still kind of ugly, right? That's still not a normal shape. So what if, I don't know, what if we dropped down right here, and then I see we got a nice right triangle over here. And the base and the height are going to be, this piece, and that seems like that's going to be a good thing. Okay, what about that leftover piece? And still kind of weird, right? I mean, I can't really find the area of that. We haven't talked about that particular shape yet. So maybe one more segment drawn in here. So now I've got this, nope, didn't want that. I want my highlighter. I've got this smaller right triangle in here with a base of 2 and a height of 2, and I have this little rectangle right here. So I can think about this shape, this patio, as the sum of these 4 shapes. So let's see. This base down here is 2, 4, 6, 7. 7 times 2. This has an area of 14 for this yellow rectangle. This is just a 2 by 1 rectangle, this little blue guy. So it's got an area of 2. This triangle is going to be 1/2 base. Base is 5. Height is what? 3. So 1/2 base times height is going to give me an area of 7.5. And then this little guy is going to be 1/2 base times height, which is just going to give me 2. So now the overall area is I've got a 14, a 7.5, a 2, and a 2. So all of those add up to give me what? Let's see, that's 21.5 plus 4, 25.5 square feet. Now, it does say to the nearest square foot, so since this is a 0.5, technically we would round this up to 26 square feet. Okay, so there's one method, breaking down a shape into smaller, more simpler shapes, and then adding up all those little areas. Well, the other way is what I like to call the whole minus whole approach, right? So let's get rid of all of these real quick. Scoot this back over. So what I want to try to do is trap this patio in a bigger shape, and I'm kind of getting the feeling we could trap it inside this rectangle. All right, so we would call that the whole rectangle, and the area is going to be base times height. And so let's see, this is 7, and then 1, 2, 3, 4, 5. So this is a 7 by 5 rectangle that's got an area of 35. But now I need to subtract away the holes, the pieces that don't represent the patio, which would be this right triangle, but also this right triangle. So those, again, this would be like hole 1, and this is hole number 2. Okay, so this is a triangle, so it's 1/2 base. It really doesn't matter which side's the base, but we can just say it's the top here. 1, 2, 3, 4, 5 times the height of 3 that's perpendicular to it. So this has an area of 7.5 that we need to subtract away from our 35. And then this one's going to be 1/2, and its base and height is 2 and 2. So it's got an area of 2. So I need to subtract away also a 2. So 35 minus 7.5 minus 2, we're really subtracting away 9.5, which gives me the same area of 25.5, which again to the nearest square foot would round up to 26. So again, there's two different ways that you could find the area of that particular shape. All right, next one. Find the perimeter of the polygon with vertices. So first let's graph these points here. So -6, -4. All right, there's point A. Point B, -3, 6. All right. C, 4, 0. All right. And D, 2, -1. And then let's connect our dots. So A to B, C to D, B to C, sorry, C to D, and then D to A. Now, initially, to me it kind of looked like maybe A, D, and C were collinear, but when I actually connect them together, I can kind of tell, right, that this does not appear to be quite the straight line that maybe I thought it was. All right, so technically this thing is a quadrilateral. It is a four-sided figure, 1, 2, 3, 4, except the third and fourth sides are almost collinear with each other, but they're not quite. So if I need to find the perimeter of this, I need to find what the sum of the four sides are. So how am I going to figure out any of those lengths? Because none of them are vertical or horizontal, I can't simply just count these. Well, we're just going to have to slowly but surely, one at a time, do some Pythagorean theorem. We're going to have to see the right triangles that really make up these sides. So just imagine going straight up from A and then shooting perfectly horizontal to get to B. And so we've got 3, and let's see, this is 6 from 4, so this should be 10 altogether. So I'm going to have 3 squared plus 10 squared equals C squared. And then over here, we're going to go, let's say, horizontally over from B until we get right above point C, and then we can shoot down from there. And there's another right triangle. And so again, we would need to figure out what are its legs length. So let's see, this is from -3 to 4, so this is 7. There's our right angle naturally, and then this is 6. So this will be 6 squared plus 7 squared equals C squared. And then down here, we're going to drop from C to D. We don't have too much distance to go there, so we have a very little right triangle. Not much distance going to be on that guy, so it's just got legs of 1 and 2, right? So it's going to be 1 squared plus 2 squared equals C squared. Let me just draw my other arrows up here so we know which triangles they're going to. And then last but certainly not least, from D, we could drop down and then shoot over horizontally to A. So there's our natural 90-degree angle. And so here is 3. And then went from 2 to -6. That's going to be a length of 8. So this would be 3 squared plus 8 squared equals C squared. And so then I got to do the Pythagorean theorem 4 times, right? I need to figure out how much this C is worth, how much this C is worth, how much this C is worth, and how much this C is worth. And I would just round those to the nearest 10th or 100th. I would not round to the nearest whole number unless the problem specified it. Now, just for the sake of keeping things short here, I'm not going to solve and tell you what the final answer is. So I want you guys to try that one out. Okay? I want you to finish this problem out and tell me what is that perimeter, to say the nearest 10th, nearest 1 decimal place. All right, which statements about the diagram are true given that angle RXW, where's RXW? RXW. Okay, so this straight line is a straight angle, perfect, okay. And ray XK, here's ray XK, bisects, what does bisect mean? Bisect means it's going to cut into 2 equal-sized angles, because it's bisecting an angle, WXB. All right, so here's WXB, which means we are allowed to put in some of those congruent angle markings, that these two angles are really the same as each other. All right? Okay, so let me get rid of all that. Let me go back and put my angle markings here. So we knew that angle and that angle should be the same because of that angle bisection. Okay, so which of these statements are true? And I will tell you that there may be more than one correct answer for this one. So if we just look at A, Angle WKX. Angle WKX. So this angle right here, that's not really even an angle that's present in the diagram. Did they mean WXK? No, they said WKX. So I will say that there's not even that angle present in here. So I would automatically throw this one out the window. Now, answer choice B, angle BXW, BXW. So this big angle right here is 117 degrees. I don't know how big it is yet. Angle BXW is 126 degrees. Well, not both of these can be true. They can't be this different values. And then answer choice D, angle BXK, which would be this angle, is congruent to angle WXK, which is this angle. Now, we know right now that that is a true statement. And we knew it was true because we were told of the ray bisecting the bigger angle WXB. So we definitely know that's true. But now it seems like either B or C, or maybe neither one of them are correct. Maybe it's not 117 or either 126, but we need to find out. So what kind of value could we put right here for angle BXK? And really the best thing to use would be, well, what else do we know that that angle is equal to? Well, we knew it was equal to this angle down here. So we know it's also negative 2x plus 35. Now, if you try setting these two angles equal to each other, you're going to get 0 equals 0, which tells you absolutely nothing. So we need to find something else that's true. And remember, we were told that there was a straight angle in this problem, and how many degrees represent a straight angle is 180 degrees. So if we add together these three angles, which make up this entire straight angle, then negative 8x minus 58 plus negative 2x plus 35 plus another negative 2x plus 35 all together should give us 180 degrees. All right, so combining our like terms, negative 8x minus 2x, that is negative 12x's. And then negative 58 plus 35 plus 35, well, let's see, 35 and 35, that's 70. So 70 minus 58 would give me 12. So plus 12 equals 180. Subtract the 12 over to the 180, and we'll get 168. And then divide by negative 12. And initially you might be kind of like, ooh, x is a negative number. I don't know if that's okay. But maybe it is. Maybe it is. We still need to plug it back in and figure out how big these numbers are. So let's see. What does that come out to be? Negative 14, if I'm not mistaken. Let's double check here. 168 divided by, and I'll just say 12. So yeah, 14, so negative 14. Okay. What were we trying to figure out? Oh, BXW, right? BXW. We're trying to figure out how big this big angle was. So if I plug back in negative 14 into the negative 2x plus 35, then negative 2 times negative 14 is 28. 28 plus 35 gives me, what, 63? And that means that this angle is 63, and 63 and 63 for this whole big angle makes it 126. So we know it's not 117, but it's in fact 126. So there's our two answers there. All right, next one up. Two angles form a linear pair. You need to remember, what does a linear pair constitute? And linear pairs had two properties. Number one, they were adjacent to each other, which really had no mathematical property to it. But not only were they adjacent, but they were also supplementary. All right, so basically it's kind of like the last picture we had here, but we would have to get rid of one of these rays so that we had one angle and two angles, and together they are supplementary because they make up a straight line, they make up that linear pair, and they are adjacent to each other. So it's almost kind of like that last picture. All right, so let's give our two angles names here. Let's give our two angles names. Let's call them A and B. So we know that angle A plus angle B, if they form a linear pair, they got to add up to be 180 degrees. Now, there are infinitely many possibilities for what A and B could be right now, right? It could be 1 and 179, could be 2 and 178, could be 3 and 177. Or we could be talking about decimal angles, and that's why there's infinitely many possible answers. But we're given another relationship here. It says the measure of one angle is 10 less than 4 times the measure of the other. Well, when they say one angle, are they talking about angle A or angle B? And honestly, it doesn't matter. So let's call the one angle angle A. So angle A is, and remember, is in mathematics means equals. So angle A is equals 10 less than, so we're subtracting 10 from something, 4 times the measure of the other angle. So 4 times the other angle has to be angle B. And so now we can take this piece of information and substitute it into our previous equation. So now instead of saying angle A, we can say, well, that's 4 angle B's minus 10, and then add to that our angle B, which still has to add up to be 180 degrees. So now combining like terms, we got 4 angle B's plus 1 more angle B makes 5 angle B's. Let's go ahead and add this 10 over to the 180 to get 190, and divide by 5, and B is what? 18? No, not quite. More than that. Let's see. 40, 38. There we go. Okay, so B is 38 degrees, right? Because B was specifically an angle, not necessarily just a normal algebraic variable, which means angle A must be the supplement of that, which is, what, 142 degrees. Now, they wanted to know what is the measure of the larger angle, and in this case, the larger angle is angle A, but if you had said that the one angle was angle B, then your angle B would be 142. But it didn't want to know if A or B was bigger, right? Because you could have named these two angles any way that you wanted to. So I would just say my answer is 142 degrees. That is the larger angle of the two. All right, second to last problem here. In the diagram, angle BDA. BDA. So the great big angle is 144 degrees. So what I would do is just kind of like, do all that fancy squiggle bracket. All of that is 144 degrees. Now, they give us some algebraic expressions for these other two smaller angles, and the question just says, find the measure of angle ADC. So ADC is this 9x plus 46 angle. Now, I'm not looking for 9x plus 46 as the final answer. I really want to know what is the measure, numerical number, of this particular angle. So we got to figure out how to put all of this together. All right? So, well, what can we do with these two things? And so one thing that I just want to throw out there is, do we know that ray DC is an angle bisector of angle BDA? Can I just set these two expressions equal to each other? Is that known to be true? And it's not, right? We don't know that's true. So we have to fall back on the good old angle addition postulate, that we take this 7x plus 34 angle, and we can add to it this 9x plus 46 other smaller angle, and altogether that's going to give us that great big 144 degrees. So now combine like terms, 9x and 7x is 16x, plus 34 plus 46 is what, 80? Equals 144. Subtract that 80 over from the 144 and we'll get, what, 64? And divide by 16 on both sides and we'll get x equals 4. Now, does that mean angle ADC is 4 degrees? No, that meant that x had a value of 4. So we need to go plug that x equals 4 into the value of x here. So then 9 times 4 plus 46, so this is 36 plus 46 gives us 80 degrees. And there's the actual measure of angle ADC, which also means, just kind of a little secondary problem here, that the other angle must be, what, 64 degrees. And I could kind of double check that if I wanted to. 4 times 7 is 28. 28 and 34, is 62 degrees. Ooh, did I mess up somewhere? Did I not add? Oh, 36 and 46. Come on, Mr. G. It's not 80. I was thinking 6 and 4. That's 82 degrees. So yeah, 62 degrees and 82 degrees. My bad. See, even teachers make mistakes. It's okay, guys. Except I don't get points taken off, right? I could correct my mistake real quick. All right, last problem. in the diagram. Ooh, now we're told that something's being bisected. Ray DC bisects angle D or BDA. So that is telling us that these two smaller angles, we can put those congruent angle markings on there, those arc marks. So now that's telling us that this 7x minus 19 for this angle BDC is going to be the same algebraically as this 9x minus 37 degree angle CDA. So now I can set those equal to each other and subtract the 7x over to the 9x and get 2x. Add the 37 over to the 19 and get what? 18? So then x equals 9. Now, in the end, what do they want to know? What is the measure of angle ADB, which is the whole big angle? So now I need to plug my 9 into really either angle. So let's see, this one, that's 63 minus 19, would be what? 50, no, not 54, 44? Which means if I also plug 9 into this angle, 81 minus 37 is also 44 degrees. So I can clearly see that these are the same angle. And so then 44 and 44 adds up to be 88 degrees. All right, those are all the problems that we're going to discuss. But again, are those the only types of problems you're going to see on the test? Not necessarily. So again, make sure you are familiar and comfortable with all of these terms. All right, and good luck studying, and we'll see how you do on the Chapter 1 test.